Hi, my name is Kylee Swenson. I am the editor of Redshift. Redshift is a publication from Autodesk which is dedicated to talking about the future of making things in the industries we serve. And I am here today with some innovators in these industries, in manufacturing, construction, and architecture. And we're going to talk about the future of work. We're going to talk about how technology is driving that, along with societal and environmental issues. And we're going to expand the conversation from where we started today with the keynote that Andrew Anagnos, the CEO of Autodesk, presented today. So we're going to talk about, for me, we've been discussing the future of jobs, the future of skills, the future of automation as a driving force of all this. And you all are at the forefront. So first I'm going to introduce you. Let's start with Vincent Wegener.
Yes.
Did I pronounce that correctly?
Sure.
Okay,
Good.
Close enough.
Close
Wegener?
enough.
Is it German? Oh, no. Okay, so Managing Director of the Port of Rotterdam's RAMLAB.
That's correct.
Okay, and then we've got Bader Al-Awadhi.
Yes.
Project Manager of Dubai Future Foundation.
Yes.
Followed by Zane Hunzeker.
Close enough.
Is it close enough?
Close enough.
Virtual Design and Construction Manager at Swinerton Builders. Jim Stoddart, Research Scientist and Designer at the Living Architecture Studio. And then finally, we have Mike Mendelson, Certified Instructor and Curriculum Designer at NVIDIA Deep Learning Institute. Thank you so much for joining us. I think this is going to be a really good conversation. So by the way, the Redshift, which is autodesk.com/redshift, debuted an article from Andrew Anagnos today about the future of work. So we're going to expand on that and talk about what does it mean. What I'm going to do is I'm going to start out by asking individual questions of each of you, and then we're going to open it up to more of a group discussion after that. Bader, I'm going to start with you.
Oh, right.
So, okay, the Dubai Future Foundation
Yes.
has a goal to make 25% of all buildings built in Dubai 3D printed by 2025. Do I have that correct? Okay. So how are you building a model to make that a reality?
Okay, first of all, it's not only Dubai Future Foundation mission. This is the Dubai 3D printing strategy. It affects the whole Emirates of Dubai, and then it will be in a bigger stage and will affect the whole country, which is contained of 7 Emirates. And the question is how we will evaluate to reach the 30% from now to 2025. Starting from 2019, the strategy will kick off, and all the building code that will have each contractor will start building a new building. They will have to start doing it by 2%, 2% each project or each building. Each year, this percent will increase till they reach the target percentage.
Okay. So what parts of the building are going to be 3D printed?
Okay, this was the common question everybody asked. Is it the furniture or is it only the building? The building code in Dubai that's working by the Dubai municipality, they have achieved that the percentage will be calculated on the structure built using the 3D printing technology. That's mean if they build a wall or the roof or the pillars. So that will be calculated and how many pillars they built to the percentage of the whole building.
Okay. So what do you think this means for the future of jobs for people who are working in the construction industry?
Based on today's keynote by your CEO, I think this will create more jobs. And more jobs, yeah. Let's take the transportation industry. They used to work with horses, now with cars. So it's always evolving. The same thing will happen with 3D printing. Now we're using like 20% to build a house, but now we'll use 1% and one machine. But it means that these 20% can build 20 houses at the same time. Then if you employed more people, that they can build like 100 buildings at the same time. So this is what I think will happen in the near future. Today, the company that says that they will build a house in 3 days, we are hoping that in the near future we can build a community in 3 days. That means 100 houses or 1,000 houses based on this strategy.
Okay. All right, so I'm going to move to Zane for the next question. So Zane, Swinerton Builders is using using machine learning to streamline its process, especially in terms of prioritizing risk in construction, using Project IQ, which is an add-on to BIM 360. So how do you envision machine learning making an impact on construction?
Well, it already has made quite the impact on how we work. So far, we've seen a lot of false positives in our data in our machine learning, and it's kind of brought us back to really reorganizing how we do it. Because if what we're doing is providing false positives in the AI, then we need to address it. And otherwise, I think we have 210 active projects. There's no way that we can actually see all of the data and pick where the trends are going and which ones have a higher risk, which ones don't have a higher risk. So it's already helping us every day.
Okay. And how do you see it changing people's jobs?
We're having to be more detailed in how we create issues, how we create some of our documentation, but outside of that, it's saving us a lot of time in the long run.
So it's saving you time, but is it going to automate people's jobs away?
I don't think it automates anyone's job for us. I think it just fills the gap that we had. Just, as far as risk goes, we can plan and plan and plan and plan, but if we don't see that a specific subcontractor or a specific company or even a specific trade might be having, take waterproofing for instance, that's the hardest one to get right. It's the one that's most litigated in construction. So if we have 2.5 years worth of data on all of the waterproofing subs in California, we can find which ones are screwing up more, which ones aren't, and we can make intelligent decisions.
Okay. For the audience here, I think it would help if you could give us an example of, I know we had in our Redshift article about it, we talked about a specific problem that was prioritized because basically the automation allows you to see something that's going to cost potentially millions of dollars if left untreated or you didn't deal with it.
Right, so currently we have set up to where we have a few hot words, water's one of them. So anytime that water is listed in any change order, any issue tracking, quality tracking, it gets flagged very quickly. People get emails, and since it's also, IQ is also tied into our schedule, so it also looks forward in time to find when we're going to be doing this. So it prevents some of it even. So we can get that alert that this subcontractor might have a high risk today because they're installing A, B, or C, and in the past they've had a problem with that. So we can keep our quality guys on that specific trade that day.
Cool, thank you. Okay, next one is for Jim. Jim, so you've been immersed in generative design for architectural space planning. How do you think generative design is going to change jobs for architects in the next 10 or 20 years?
I think we've actually been laying the framework for and the foundation for using automation for the past decade. I think this transition to BIM, the introduction of kind of parametric modeling solutions, we've actually started to restructure the way we think of design problems from being kind of abstract and representational to being much more highly structured. And structured problems are inherently good problems for computers to help solve. Computers are not good at kind of open-ended creative solutions, and that's always something that humans have been involved in. But we've set it up in a way that we actually now are getting tangible benefits through automation and BIM, where we're able to save time doing repetitive tasks, and we can then reinvest that time in improving design, or with parametrics, the ability to create rapid variations without having to kind of redesign from scratch. And so the I think the adoption of generative design and automation is kind of inevitable just because we've already been kind of setting down all of the base technology for this. And really it's just stitching together things that we already have. We already have models that we can vary. We already have simulations that can give us feedback in terms of how our designs perform. And now we're able to use automation to actually combine those two things to start exploring designs and getting feedback live and actually progressively developing better and better designs. And for us, it kind of changes the role of the architect because now we can both have more confidence that we've kind of thoroughly explored a design problem, and then we can go to the client and actually feel more informed about the designs we're offering them with actual data about how we think they perform and be able to make kind of informed decisions about the trade-offs that are being made and choosing the kind of final design to execute.
So I've heard some architects express concern that generative design could take away from the creativity because the computer's aiding in that part of the process. What do you think?
So, I mean, the computer and the automation part is really just kind of twisting the knobs, right? It's changing parameters of the design system, and it's looking at what the scores that are coming out in terms of how well it's performing. But the actual design of the problem, the actual design of the geometric solutions to that problem those are things that are still well beyond the computer being able to solve. I actually don't even know if there is like a clear point without some sort of like general AI that you'd actually be able to have a computer coming up with solutions for designs. So I'm not really worried about the kind of the loss of the role of the architect, the role of the designer. Like that is always critical. The thing that's I think kind of scary for architects is that it changes again the way we think about designs in the same way that we had to change the way we design when we shifted from just 2D CAD drawing representations, abstract representations of space to actually defining systems that are related to each other in BIM. We'll have the same sort of challenges and kind of rethinking how we define design to create good problems for generative design to help solve.
Okay, thank you. All right, so Vincent?
Yes.
So with RAMLAB,
yeah.
It's an R&D part of at the Port of Rotterdam. So your aim is to manufacture large metal parts on demand. That's the goal, right?
Yeah, that's right.
How are you going to get there?
Right. Well, a little bit of background on RAMLAB. So that's Rotterdam Additive Manufacturing Lab, and it was initiated last year by the Port of Rotterdam Authority. The Port of Rotterdam used to be the largest port in the world, and now it's the 11th or 12th. All are based in China now. So they are pursuing a new strategy of becoming the smartest port in the world. And yeah, what is actually smart? If you look at the Port of Rotterdam now, there are a lot of warehouses just stacked with stuff that will never be used. So there are studies that show that 70% of parts, of spare parts, will never be used. So you can imagine it takes all the logistics, and all the work to store a part and then to make it and then store it and never use it. It's not a very smart approach. So the idea is to make parts on demand, and in our industry, in our sector, everything is big and made out of metal. So that's our aim, and we just finished our first project. You can see it in the exhibition hall. It's our propeller. So it's made with wire arc additive manufacturing, and we hope to make a change in that. Yeah, we can make in the future. We can make it on demand. Okay,
and then how do you feel that's going to impact in the industry and people's jobs in the industry?
Yeah, well, if you look now, for instance, at propellers, they are often made in other countries far away from the Netherlands, so Spain, for instance, or China, and so the work isn't even in the Netherlands. It would mean that the work would come back to the Netherlands in that sense. So that for the Netherlands itself, for the Port of Rotterdam, it would be a better way for the region.
Okay. All right. So last question is for Mike. So first of all, I think it would help if you could explain the difference between deep learning and machine learning for me.
Yeah, absolutely. They're not different. One is part of the other. Deep learning is kind of the state of the art in machine learning currently. if you think about intelligence as the ability to accomplish a complex goal, learning is the ability to accomplish a more complex goal today than yesterday. So it's change in intelligence over time. So if we have machines that can learn, then our solutions will get better. We will be able to accomplish more complex goals with the same machine as it follows our process. Deep learning is inspired by the human brain. So algorithms that are inspired by the human brain, they're not the human brain. The human brain is much more complex than these algorithms are. But as they've gotten deeper and deeper and deeper, and by deep, it's basically it's a large composite function. If you think back to like high school algebra and you had f of x, now you've got like f of g of h of I forever of x. So a very deep function where the idea is that you can approximate any function. And so a function is just a mapping between some input and some output. So if you have some input that you have all the time that corresponds to an output, you can feed that to a deep neural network and it will learn a map between them. What's fun for us as practitioners in the room is that since it's inspired by the human brain and our strategies for teaching it are inspired by human learning. So all the strides in deep learning are really motivated by the things we know about human learning.
Okay. So my next question for you is actually how will it solve some of the world's biggest problems and then also sort of pave the way for, you know, giving rise to new industries and new job types?
Since if we take that claim that we can create a universal approximation function, any map between any input and any output, then we start to get to just dream up input and output mappings. When this happens, what do I want to have happen? When I detect water in a work request, I want it to be flagged. How that happens, I don't really care, but like here's the action and here's the response that I want. So instead of having to be able to walk through the steps of how to go from some input to some output, our job becomes really to find good input and output mappings, like ideal inputs and outputs, and then let our networks learn them. So our job becomes to ask bigger questions.
Okay. All right. So 5 of you are all at the forefront of the future of making things. And you're impacting the future of where industries are going. So I'm wondering, I mean, is it scary in any way? Are there any concerns you have? And this is just open to any of you to jump in. None of you look scared at all.
I think we're all optimistic.
So all right, so why? So you're excited. So tell me why.
Yeah, well, for me, I'm working daily on new stuff. So that's every day is exciting in that sense. I can imagine it was mentioned this morning as well. So there's a group of people that will need training, or they're more scared of what's coming. But I think it's our job as optimists to convince them that that's a bright future instead of.
Why are they scared?
Why? Well, as humans we don't like change, so. That's true. So that's, I think, and there's a percentage of the population that is optimistic and is willing to change. So we have to lead them, I think. Yeah.
A lot of the fear that I hear in teaching the basics of deep learning is around a solution that humans don't fully understand, or the way of arriving at a solution is something that we, as the person who designed a system, or at least gave it inputs and outputs, don't understand. So for instance, if we talk about a self-driving car that has an accident, that we don't know what part of the algorithm caused the accident. But reframing it as a human problem, if I crash into something, people don't come in and try and figure out what part of my brain made me crash into something. It's a data problem. It's what learning do I need to become a better driver? What systems and rules do I need so that in general, we all crash less. So it's more outcome-based than algorithm-based. And so it's a different way of assessing what went wrong, because things go wrong. We're not perfect.
Yeah, I think in the design world, that kind of, when people get scared about automation, really it's a the real cause of that is kind of like a laziness, right? Like we can apply this technology to, let's say, yesterday's problem, but then we essentially kind of like, we've created a macro to repeat something we've already solved. So for us, the challenge always is when we can kind of apply a new technology is to question, okay, now that we can do something that's able to deal with more complexity, we should redesign the way we formulate the problem. So like an example of the office space we designed for Autodesk in Toronto, we can kind of like, there already are ideas about what makes a good office space in terms of things that are very easy to measure quantitatively, like daylighting, like ways of making sure that it's not visual distraction. But some things like human preference in general in design, because they're too broadly complex to kind of solve kind of manually, we've developed kind of heuristics, we've developed rules of thumb to solve these problems. And so we generally apply kind of a blanket solutions. And so in this case, now we said that we actually have a system that can navigate really complex designs. So let's actually just throw it all at it. Let's give it access to everyone's preferences in the office and have it come up with solutions that not only produce kind of things that are holistically understood as being good for office design, but are also kind of meeting nuance of individual desires, individual preferences. So I think it's always important to keep challenging what kind of we're proposing in terms of design to kind of meet the ability of the technology that we're implementing.
Okay. All right, so how can we change this, that there's a negative perception about automation? As Andrew said, for more than 50 years, I even saw an article from 1928 in the New York Times about automation taking people's jobs. So how do we change that negative conversation to something more positive for people?
I think, well, this has come up in past years AU, especially in the talks by the CTO, Jeff Kowalski. There's kind of this disconnect of these kind of abstract terms. So like the notion of robots, for example, are scary to some people. But if you actually think about like the things we call robots are things that we don't really have a clear definition of what it does. Like actually a lot of the technology and a lot of like the tools we use, if you think about it, are actually robots. Like a printer is a robot. Like household devices a lot of them are actually like the base functionality is a robot. But the moment that we kind of assign a task and assign a label and like specify what it's doing, we suddenly stop worrying about it. I think automation is something similar. Again, we're actually doing things right now that are automation, but we've relabeled them something different. So like if I'm designing something in Revit and it's automatically producing coordinated documents to construct it, I'm not worried about that. It is automation. It's actually doing all these things that I used to manually do, going through and kind of coordinating plans and sections and elevations and kind of eliminating those tasks, but I don't worry about it because it's gotten a new label. It's gotten specified as something else. So I think part of it is just that the moment we like understand what it's doing for us, the value it's providing, and we give it a different name, it becomes less scary. It's kind of like a human problem of like, again, these broad things that don't necessarily have clear applications. And I don't know if what the solution is, because in the same sense, we're still kind of nervous about robots, we're still nervous about automation. But I think we're going to get to this point where like start becoming more and more prevalent, and we're just like the worry goes away.
Yeah, in construction, everybody's worried about the actual labor being replaced by machines some way or another. For most typical construction, there's not a whole lot of repetitiveness. And that's what machines are best at, is repeating things. So if we're scared about repeating, I don't know, picking something up, I feel like that's a little ridiculous. You should be glad that you don't have to pick up this bit. Makes you faster at install, which makes us more efficient, which means we can do more work, which means you get paid more. So I don't know. I don't see, well, I do see, because we deal with people that are right near retirement and right coming out of school, and there's a little bit of a difference in mindset. And it's slowly changing across the board. We're using a laser, I forget what it's called now. I think it's I don't know. Anyway, it's not important. What it does is it has two lasers, and our layout foreman for our drywall crew, he just has a CAD background. And he clicks what he wants to come up, and the two lasers cross, and that's where that point is. It automatically does all this. It sets it up. It's really, really easy, and it makes us faster. So we can employ more people to actually do the physical work.
Yeah.
I would play devil's advocate. Sorry.
No, it's okay. From my point of view, that automation, it will accelerate our future. It will close the gap between what he said, the high school graduate and the senior. I think the automation will also help us to build faster future. And I think we should be very optimistic about the automation industry, and we should accelerate the R&Ds and accelerate the funding and everything that will help this industry to develop and reach higher.
What you're talking about a lot is the housing shortage, right? Now, almost every developing or major city in the United States also has a housing shortage. So it's solving more problems, is really what it is. We're trying to catch up to where we need to be, right? It's not where we're going, it's where we should have already been.
It's like for myself, I'm not worried because I am in it, but I do see the fear coming from, or work to be done, I should say, with regards to education. The way we deploy knowledge will have to, I don't think that we're currently set up to take that acceleration of new ways of doing things and deploy it to our entire workforce. As technologists, like all in this room, like we can be excited. Whatever's coming, we can learn something new. We're here. We chose to come here to learn something new. I don't know that we can speak for all of society as a whole. All of society would love to get in and learn and do things better and solve these problems. But I think we've got work to do in how we rapidly deploy knowledge, not just information. It's all out there, but like mastery of new concepts.
Right, so training is obviously a huge aspect of this, and the training is available to, there are a lot of people who can access it. However, it's not, my question is, how do you unify people with automation rather than divide people? You know, how do you make this accessible to everyone?
I happen to be also co-founder of a makerspace, so and what we have done you have to start early, right? So we give kids from 8 to 10 classes in 3D printing and 3D design, and I think we should start at the early age so everybody is familiar with technology around them. I think young kids already are natural, adopting new technology, but the issue is that the teacher is, at least in the Netherlands, most of the time they have chosen to be a teacher because they don't like technology, but they like to work with kids. So now it has become mandatory from a national level to do something with technology. So from 2020 on, the teachers have to provide classes in science, technology, and whatnot. So, but that's I think the start, is to educate young kids.
Right.
This topic.
Then our job instead, like we can ask teachers to become technologists, or we can also ask technologists to become teachers. Yeah. So the skill of teaching becomes really important. And yeah.
So yesterday I interviewed the former Secretary of Transportation, Anthony Fox, and he was saying that planners, years ago, city planners would actually create plans that would leave people out. It would leave communities out of, whether it's dividing, certain areas of a city with the freeway, or making it difficult to get to the beach because there wasn't proper transportation there. And he's saying, this is so important in thinking about, future of infrastructure, multimodal ways of getting places, and with automation, I think there's a huge opportunity here to make sure that it unifies people. So I just wanted to dig into that a little bit more. Do you have any thoughts on how, for example, you were saying, technologists can be teachers, teachers can become technologists, but it's not in every school, It's not, where I live in Oakland, it really differs by where you live. So how can we get more of this training and this education to people?
I mean, this is my day-to-day job, right? Is to deploy. I sit with domain experts in deep learning and parse out what are the fundamental skills that somebody needs to be successful, and then create learning experiences to build those skills, concepts, mindsets, and then train the community of teachers to go out and run them. And right now it's like internal at NVIDIA or with our customers or at conferences, but the real work to be done is to build, I think, communities of expert teachers that are accessible. So it's like, it's blowing up the entire current school model, but there's somebody with downtime right now who knows how to solve the thing that you're challenged with. And whether that's you're in 2nd grade and the thing, and the 3rd grader knows the thing that you need because maybe the teacher hasn't done that, or so whether the community's in a school, the community's in the Autodesk community, the community's in the NVIDIA developer community, how to like learn what people know, teach them to teach, and then connect them with each other is kind of the work that's in front of us.
With my department internally, we have a 5-minute rule. If you can't figure it out by yourself, you have to go ask somebody for help. Oh. So it kind of eliminates some of that because we have such a wide expertise in our company specifically, but a lot of GCs have a lot of good people. So if you're just willing to share, it makes everybody better. It's all about raising the floor of intelligence, not about training that person or that person. And
some of the work that I think we're working with has actually made it, like, reduce the barrier to entry to these fields. You can get a very creative person who is a terrible draftsman, who can now like be in VR, experiment, like actually like living in the space they're trying to create. They can engage. So
yeah. Similar in some of our older staff, we're putting them in VR. We're putting our old cranky superintendent on drywall that's been doing it longer than I've been alive. And he is now taking our baseline model of all of the studs that we want to put in. He's looking at it and he's saying, I don't like how that is going. Let's change that over there. And let's make this one over here a little bit better. This is too narrow. I can't put a lift in there. And it informs our new design. So it can go the other way too. We learn a lot from the expertise, and it's just making a format that he can actually purvey that to us. Also, it kind of goes both ways.
Perhaps in the near future, you can also have an AI assistant or a teacher. You can ask, like you said, in 5 minutes. Yeah. Instead of asking somebody else, just ask your AI assistant.
That would be really cool.
I think on our end too, like if we go like this barrier of entry is one thing I think is definitely really critical to making sure that kind of people have access and understanding of the tools. But even on the kind of expert end, I think the tools are letting us actually start to challenge our assumptions about how we do design. I think, again, most construction and manufacturing, maybe not manufacturing, but at least construction and in the building realm is still, everything's a one-off. The prototype is the building, and that's the final object, even in infrastructure. And so we don't really have many opportunities to kind of iteratively test ideas. And I think one of the advantages we're seeing of the kind of the new technologies is, again, if we can trust simulation in the software, which again is like a bigger question, like is it validatable? But the moment we can validate it, we can trust it, we can actually let it start to explore ideas in kind of a broader sense, not only to like kind of confirm the things that we already know, but ideally to show us alternative ways of doing things that we may not have thought about before. Because again, in the past, we will generally try to stick with something that we know has worked in the past, even if we're not necessarily confident it's really the best way. We just have confidence that it works good enough that we're not going to get sued, or you know, there's not going to be that many traffic jams, or there's going to be an acceptable amount of traffic jams. And so I think the value to kind of the expert end is that, again, you never kind of finish learning, that the systems can always kind of challenge our assumptions of where we've stopped learning and kind of keep pushing us to kind of find new solutions in the design of problems.
I love where you went with that earlier, that we can think about automation replacing our jobs, because if we kept doing things the same way we had been doing, then it would do it for us. Cool, we're out of a job. but kind of in an entrepreneurial sense, as soon as someone comes in to do your job, you get to kind of level up in a way and say, well, now that I have this new capability, let me reimagine the entire workflow. Yeah. So you're kind of continually reinventing the process.
Yeah, and we've been really interested in, like, the idea, again, is old. It's, 60s earlier, this idea of like actual computer-aided design. And again, we talk about this a lot, that actually the tools we got are more like computer-aided drafting, the kind of faster versions of the pen and paper, kind of simplifications there. And I think now we're at the point where the computation power is there, and we've started to structure our problems in a way that we can actually implement computation where we can still leverage the things that humans are really good at, the human intelligence, the creativity, but then also leverage the machine intelligence, the specific capabilities of computers to solve problems really quickly, as long as they're well structured, and combine those together to find a way to kind of a hybrid approach that actually is better than what we've been able to do with one or the other separately.
Okay, so in the keynote today, Andrew talked about building better, building with less, building, what was it? Sorry.
More with less.
More, better with less. Yes. And Zane, you were talking about how we're not there yet. We have a lot to do. We have like a crumbling infrastructure. There's infrastructure that's not even been built. There are, by 2050, it's estimated that we're going to be at 10 billion people on the planet. And apparently, we need to be building 1,000 buildings a day just to keep up with the population growth, which sounds insane to me. So,
we're doing 200 of them.
What's that?
Swinerton's doing 200 of them, so we've got our part.
Okay.
No, I don't know. Everybody needs to be doing better. That's the only way that I can really explain that. Is we need to raise the floor of the intelligence. We need to raise the floor of the efficiencies and the trust between technology and people. The only way I think we can get there.
Well, so it sounds like there are many opportunities to be doing a lot more than we're doing, and we're not going to get there without automation. That's not going to be possible.
I think that's a correct statement, yeah.
Right. So how is automation really going to augment people, and how is it going to make it possible for us to build more with less?
Well, we're going to have less waste. For instance, we're looking at doing prefabbed wall panels for our drywall group. It's not quite there yet in terms of the cost to entry, because right now to buy the machine that can take the computer model and automatically cut out all the studs is $1 million currently. So that's kind of hard to swallow. But as we keep moving forward, we're also getting our crews more efficient. They're becoming much more tech savvy. Almost all of our foremen have iPads now, and I make sure that every single one of them has access to the model. Whether or not they actually open it up, I don't know most of the time, but I make sure they at least know how to use it and that they have it. So that way, if they feel so inclined, they can. But we're just not seeing the return on investment yet for a lot of the automation in typical construction. If it's repeatable, like bathroom pods for hotels, those are prefabbed frequently in construction. They put the toilet there, they do a subfloor, they have absolutely everything in a box, lift it up with a crane, place it in a recessed slab, and it fits perfectly. It's just for anything that's not typical, the one-off solution, especially in manufacturing, one-off solutions are 1,000 times, or if not more expensive than a repeating design. So unless we go completely in design to repeating functions, which I don't think we will, because we have so many different clients that want completely different opposite-ended things that it's really hard, and that's why construction has fallen behind agriculture and manufacturing in terms of automation, because there isn't a whole lot. When you look at the grand scheme of things, there's almost nothing that is typical. Even within our own projects that have typical floors, there's one room over in the corner that's not the same. Thanks, architects, by the way. But I mean, it's something that we all work through. So unless we converge and all agree that it's going to be typical, we're not going to see massive jumps in automation and construction. We have equipment and stuff that helps us, but it's not automated is the problem. And we're getting there with certain projects that can be, because they're typical, and it repeats hundreds and thousands of times.
Yeah. Yeah. So I think from a port's perspective, of course, the business is to transport stuff around the world and to unload it, and therefore warehousing is the business model of a port Rotterdam. So hopefully we can go to a world where we have digital warehouses instead of physical ones, and also I think the quick gains in machine learning or artificial intelligence could be in optimizing the demand, the logistics, so you only make what you need, and hopefully you can make what you need locally instead of transporting it all around the world. So that will be at least that will be more with less scenario. So, and that's, I think, also with printing houses locally.
Yeah, it's the same concept, but now we're talking about the automation, not the 3D printing. 3D printing is the same concept. If I want to print the house, I will replicate it again and again and again, because it will be more, it will reduce the cost, reduce the labor, and it will be faster to do the same concept at let's say the community with 100 houses. The same design will be faster than different designs.
Yeah.
Same concept.
Okay. So, I mean, obviously we talked a lot about automation, but there's so much more technology at play here. So there's AR, VR, MR, generative design, additive manufacturing, reality capture. How will all of this innovation, all of this technology sort of lift up the baseline for everything you do?
We try to do AR and VR on a lot of our projects. The perspective gain from doing that it's uncomparable to the way we used to do it.
In a big way, it feels like it's a more intuitive way to communicate with our machines. So in AR and VR, you can get into a space I'm going to use this word kind of freely, but as a listener, to consume and understand something better. So instead of having to learn to read a like old school CAD drawing, you're in the space.
You feel it.
Yeah, you feel it. And so to lift up the work that we can do, instead of spending our time trying to communicate based on the constraints of our machines, like if you look at a keyboard, there's just a pile of letters that are organized to slow us down, and the letters were made by humans, and spelling was something that we invented. That's a technology that has held people back. And as we go to like communicating by voice, which is how we communicate by showing, which is how we can learn to understand something, instead of trudging through the constraints we've put on ourselves to communicate with either our machines or each other globally, we can instead take what's in our heads and communicate it with our team or with an end product more accurately and better.
Yeah, from a manufacturing perspective, it's the keyword is or a key tool right now in the future even more is simulation. So if we can make more in the simulation, we don't have to make it in the physical world, and yeah, you won't believe how much waste is produced by just making the first batch or the first 1,000, 10,000, and then you have to scrap it and start all over because your tool wasn't right. So I think simulation will also help us a lot in yeah, doing more with less.
Okay. So you touched a little bit on sustainability. I'm wondering, I mean, obviously the planet has limited resources, and that's why we're talking about doing more with less. Climate change is a factor for sure, population. So how will you incorporate sustainability into your practices and your firms?
I mean, on our end, again, since we generally exist at the beginning point of a production of a building, like we have possibly like the greatest opportunity to have an effect on that. Like the early design decisions are the ones that may actually have big implications down the line. We can obviously make a lot of kind of course corrections in construction and selection of materials, but if the design's already set out, then that already kind of like really limits our ability to kind of make any sort of changes, meaningful changes to improve ideas of sustainability. And again, I think we're at this point now, we have kind of the technological capability to get both immediate feedback, and we have the tools to do kind of scenario exploration. So rather than kind of make, again, base assumptions on like, you know, we're going to build buildings so that they ideally last forever, we can actually take ideas like, you know, we actually need to build a building that lasts for 25 years, so how can we design a building to effectively disappear? Can we actually introduce the constraints in the scenario that the system's exploring, where it's looking at things like embodied energy materials, recyclability, reusability, to actually kind of come up with solutions that fit more, let's say, restrictive ideas of material usage, rather than, again, making this assumption that kind of buildings are going to be around for all of time. And like on our end, we've done like a lot of work with kind of experiment with materials. Some of it's been kind of on the more radical end, like designing buildings that can be built out of grown material that can be, again, composted away at the end of the building's life, which, again, are probably several steps outside of what's actually going to be implemented in the realm of kind of built architecture for people to occupy. But I think, again, we have the tools now that we can actually start exploring how we can start integrating these ideas in an early phase in the design process and have that sense of confidence that we actually are making good decisions in terms of our material usage, in terms of our energy usage, in terms of the kind of further down the line implications of trying to keep our buildings from ending up in landfills and being that 40% of landfills like Andrew mentioned this morning.
I think that for sustainability, to actually achieve that, there should be an incentive right now to work towards that. And one problem now is that the price of pollution and carbon is not included in the production of your part. So right now it's cheaper to manufacture a propeller in China and do it in the Netherlands. But if you incorporate the burden on the environment in that price, perhaps you can compete on a local scale. So of course it's not a new solution, but a tax on carbon would be one of the solutions to actually see what is the actual price of a part that you make. And that will even stimulate even more to stimulate it first before you start producing it. So hopefully that's one of the solutions for a sustainable world.
Bader, could you talk a little bit about sustainability for the Dubai Future Foundation?
In general way for the Dubai Future Foundation, not just the 3D printing strategy. Of course, the sustainability in our projects is making sure that they are going on, like we have the Dubai Future accelerators and how to keep the accelerators going. We have a lot of challenges that comes from the government entities of Dubai, and we post it online, and each of the startups that's around the world, they can give us the solution of these challenges. And then we will host them there in Dubai for 9 weeks to produce the challenges and help us solve it out. And this acceleration will go on every 3 times each year. And now we reached the 3rd year, which is a big success. And they have solved a lot of problems in waste management and solar powers. And we have now recently just announced the biggest solar power in the Middle East, and that's part of Dubai Future Accelerators project.
Okay. So Andrew was talking about future industries, and I loved his idea of, having this sort of paver that traverses across the road, and it's chewing up the pavement, and it's reprocessing it and spitting it back out and repaving the road all while we sleep. Maybe that's going to happen. And he was talking about You know, the idea of recycling cars, recycling all of the combustion engine cars that are on the road today and recycling them into electric cars. You know, in terms of sustainability, do you imagine, I mean, can you tell me what you think might happen in terms of new industries? I mean, they're going to be like, are there going to be new industries, new companies that are going to be recycling those combustion cars and kind of helping drive all of this forward?
There's already companies in construction that help us demolish and separate everything out. So, I mean, that helps. It's not exactly the same, but there's definitely reuse going on. It's not as big as taking all the cars that are junked right now and recycling them, but there is some of that going on in construction already.
It feels like an ideal solution would be thinking about it in the design phase, where like taking the materials that we chose to make those cars with 1, 2, 20, 30, 40 years ago, recyclability, reusability wasn't a driving factor, and now with the skill set that we're building as a society, if we start to do that now, then maybe we don't just continue to exacerbate the problem. I wonder about how to make use of all of the old cars, but as far as moving forward, absolutely, there's no reason we shouldn't be thinking kind of a cradle-to-cradle model.
Yeah, I think our historical model of looking at these things has been, again, to kind of limit the scope of how we evaluate it, just because it, in general, is a huge problem. But again, now we're at this point where we can actually fully consider all of the embodied energy that went into a particular material, from its extraction from the earth to all of its processing to what it'll be like at the end of life, to recycle it or return it back to waste, or ideally be able to reuse it. So yeah, we're at the point now where we can do these things, and we generally do them kind of after a building's designed. We'll run a full analysis to meet LEED requirements. But on our end, we're more interested in what happens if we actually do this as we're designing. If we can actually get immediate feedback as we make a design change, and if an automated system's exploring designs, it can actually find better solutions. And sometimes we run into problems because, again, usually to get the answer to a complex problem, you need a complex input. But I think there's also advantage of things like using machine learning to actually kind of take learnings from past designs, reduce the dimensionality of a complex problem, and be able to project it back onto kind of these abstracted solutions. So we actually, again, can know something about a building in kind of a sketch phase, and give us a sense of what its impact is going to be in terms of material usage, in terms of energy usage. So again, the technology's there. It's just kind of up to us to start doing that earlier and earlier and earlier, so we can actually have more and more influence on kind of solving these problems head on.
So before we see waste, before we're dealing with circular construction and all of these other ways of preventing waste and reusing, we're trying to do way more with a lot less.
In construction with our subcontractors, they prefab a lot. So in BIM, we'll detail everything out down to the 1/4 of an inch, and then they'll send it to a CNC, and that'll get fabricated, delivered on site, and we'll just piece it together like Legos. On a really well implemented project that has very capable subcontractors and good management on all sides of the planning, whether it be architecture, engineering, the subcontractors, or the general contractor. If we all have a good head on our shoulders, we can actually reduce quite a bit of waste in construction if it's done properly. A lot of times we end up with owner-driven change or something that completely screws that entire workflow up. But it is possible. It's a little far and few between right now.
And I think we're going to end up seeing some of the kind of the societal political pressures that have been put on manufacturing towards kind of enforcing this idea of dealing with the waste. It's like the notion that now Apple has to design a robot that can take apart their phones to make it easy to recycle. I think inevitably we'll reach a point where that is going to spread to also the construction industry and to the kind of larger systems we're building. So if that's inevitable and we have the tools to deal with it now, we should be thinking about it now to actually kind of head that off and be a front of the pack rather than responding to something as it's kind of imposed upon us.
Right.
Okay. Well, thank you so much for joining us. Thank you to the panelists. You've been fantastic. I guarantee there will be more content that will come from this that will live on Redshift.